Tremendous, huge thanks, Eva, for that wonderful introduction to this entire webinar and to this entire field. I've already learned so much, and it's always lovely to see a whistle-stop tour of some of the most exciting research that's coming out of your lab at the moment. And just being part of today's session is really, really exciting. And I cannot wait to hear from our other speakers and to tell everyone today a little bit more about this first challenge. So we're going to be talking about from observation to interaction. And I'm going to tell you a little bit about some of the work that my team has done into probing the flexibility of social perception in order to reveal insights into observation and interaction, particularly with artificial agents. All right, so I'll begin by placing this research within a broader context. So this first challenge speaks about from observation to interaction. And if you think about it, observation and interaction of other humans is something that we're all doing continuously, pretty much from the time we wake up in the morning until we go to sleep at night. We are seeing, watching, and interacting with other individuals. And this is essential that we're able to do this and to read others' social intent and organize our actions with others in order to achieve all manner of trivial to really complex goals. So whether that's raising your hand in class, when we used to have in class and in-person meetings to ask a question, or something as complex as climbing a mountain, running a race, or any of the other brilliant things we're going to be seeing in the Olympics over these coming days, all of these things require really quite sophisticated dance between perception and interaction with other people. So that's all well and good. The human brain has evolved over millennia to achieve this somewhat effortlessly and very quickly and efficiently. But an interesting question for many of us gathered here today and interested in what the future holds is, how is this neural and cognitive machinery that's evolved for observing and interacting and making sense of other people, how is this going to be co-opted, and how are things going to be different? What opportunities, what challenges might we encounter the more and more it's not just other humans that we're engaging with in our social spheres, but it's also really sophisticated and quite unusual artificial agents. So this is a really, I think, important question, and understanding how we can best understanding how people might coordinate, cooperate, engage with types of social machines that we see here and that we'll see across today. It's going to be really, really important. So we know that, you know, as Eva has said, and you can't really pick up a newspaper or click on the news without hearing about, you know, the rise of the robots, and there's more and more money being invested into artificial intelligence, into these artificially intelligent social machines. So there's a proliferation of these agents, but we still don't have quite a grip yet on what's going on in the human brain when we interact with them. There's this idea so far that, okay, well, if we see a robot playing basketball, we're going to pretty much, again, use the same kind of neurocognitive architecture that we'd use to make sense of a human. And we'll just kind of say that that's more or less the case, and we can use that as a template. But what my team and several others around the world are arguing is that, well, actually, it's not just, you know, when we see a robot doing something that's vaguely human-like, our brain isn't necessarily just thinking, oh, that's like a human in a robot suit, and I'm going to respond to it accordingly. There's actually a whole bunch of other things that are going on across the cognitive spectrum. It's not just social processes either. And we talk about some of these things in a recent paper, a colleague of mine and I, and you know, we talk about the impact of Hollywood films, which is actually really quite peculiar, or maybe not just Hollywood films, but just media in general, how this is shaping our perceptions and interactions, as well as our understanding of tools and machines versus kind of other non-human social agents in general. And kind of this important point that Eva mentioned as well, how much time you spend interacting with an agent. All of these things and many more besides are really going to shape how we're perceiving and interacting with artificial agents. So it's not just going to be that we can take human social cognition and kind of patch that on as a one-size-fits-all. So I think this is an interesting space, and I think a lot of the talks that we're going to hear in this session today are going to help us understand some of that subtlety and complexity a little bit more as well. But we might want to be asking questions, or people in this group in particular, about how we perceive and interact with these artificially intelligent machines, but kind of taking this question back one more step and saying, well, why should we actually care about this if I'm not really interested in social neuroscience or social perception? Why is this interesting to me? And what I would argue kind of is a slightly bigger picture reason why we should care is that if we can understand the human neuroscience that kind of underpins these day-to-day or these even laboratory interactions with artificial agents, this should help us develop improved design and programming of agents that are more socially engaging and more socially cooperative with people. So ultimately help us to build better robots, which is important. And equally important, especially for those like me who are coming from cognition and brain science to begin with, is that a deeper understanding of the flexibility and limits of human neurocognition when we engage with humans or with artificial agents will help us to understand kind of fundamental truths about the human brain and human cognition and how we can learn and develop and flexibly adapt based on what our environment gives us. So I think there's some pretty big reasons why this is quite important stuff. So we have been examining questions in this domain for the past several years from a social neuroscience perspective. And I'm going to focus on some, I'm going to say slightly older work from our team, but we'll say more foundational work. And that's only because of the challenge that Eva has tasked me with. This kind of observation to interaction really kind of speaks to some of the earlier work we've done, but kind of even the recent work as well is all variations on this theme. Of how we can use social neuroscience tools to better understand observation and interaction with social machines. So one of the kind of theories that we've borrowed from developmental psychology poses the question, to what extent are we kind of driven towards making sense of artificial agents based on this like me idea? So am I really seeking out self-other equivalences in the environment? And if that robot is dressed like me, or it talks like me, or it has kind of a movement pattern like me, is it going to be much more easy for me to interact with it compared to if it looks like something like Wall-E or any of the robots we see at that, or some of those interesting robots in the dark path that Ava just showed in one of her first slides? To what extent do these things matter? So one of the ways we've been getting at looking at these questions is to ask some questions about stimulus cues. So what does a robot look like in terms of how like me is it? Is it there in the room with me? Does it have a human-like form? Does it move in this really rigid way, or does it move in a human-like way? Also, what do I bring to the interaction? What's my prior experience with robots? Is this something that something that I'm really familiar with? I've watched a lot of films, or I've come into the lab to do lots of different experiments, or is this totally brand new and really exciting? What have I been told about this robot? What do I believe? What's my propensity to anthropomorphize? So all the things that I, as the human, bring to the table are really important and also quite difficult to pin down. And of course, the interaction between stimulus cues and knowledge cues is really important as well for understanding what's going to go on and how we're going to design agents that are optimal for whatever social task they're supposed to perform with people. So I'll give you a whistle-stop tour of 3 different studies where we've kind of addressed some of these questions. And I've just realized that I can't quite see my timing. I'll just use it on my phone. But Ava, I can see you, so if you can give me a T when it's time to wrap it up, that would be great. One of the first questions we'll address here is how the neural mechanisms are impacted in social perception. Neural mechanisms that we know are engaged in social perception are engaged or not when we're observing non-human form and motion cues. So these are kind of the stimulus cues. Also, we'll address how visual cues and expectations about an agent's social origins shape our perception. And finally, we'll take one tiny step towards interaction. I know we're going to be hearing some talks a little bit later today, and far more deeply interactive studies. And this one will just be kind of the tip of the iceberg about taking us from observation to interaction. So in this first study, we are interested in exploring how stimulus features shape perception of artificial agents. And we often make use in the lab of 2x2 factorial designs because they're particularly robust for the types of neuroimaging questions that we're interested in. So in this particular study, we had kind of 2 factors looking at the motion profile of agents. So we could have either kind of familiar human-like motion or rigid, jerky, robotic motion. So you can already see that one of those motion types is like me, the other type, not so much. And then we can also add on top of that either a like me form, so a human form, or a very much unlike me form, a robot form. And what we did is we filmed a bunch of videos that would kind of fit the bill across this 2x2 factorial design. And we had a human breakdancer performing kind of natural movement and then more rigid robotic movement. And then we used stop motion cinematography to animate just a very cheap Lego robot to do those same movements as closely as possible. And what we found, this was across two independent fMRI experiments with two different participant samples, is that by and large, when people were watching the kind of more like me movement compared to the less like me movement, so the natural dance compared to the robot dance, we don't really see widespread engagement of these typical social cognition brain areas. Instead, we only see really early visual cortex coming more online for the more familiar social stimulus, whereas when people are watching the much more unfamiliar, unlike me, robot movement compared to the familiar movement profile, here we see quite widespread and robust engagement of parts of what we call the action observation network, but also parts of the brain implicated in more social processes such as perspective taking. So we have, it's tiny on the figure here, but we have bilateral premotor cortex and inferior parietal lobule, as well as occipitotemporal cortices. Interestingly as well, we ran this not identical study, but with the same stimuli, we ran this study with functional near-infrared spectroscopy with 4-month-old infants. And we find some really interesting corresponding evidence that suggests even very early in development, when infants have very little experience with the world, we're seeing similar patterns of findings using FNIRS in the infant brain. So what we can conclude from this is that stimulus cues to humanness in terms of form and motion weren't necessarily necessary for engaging brain regions associated with human action observation. And this is already kind of like the first chink in the armor to suggest that when we're engaging and seeing robots, there's a lot more flexibility in social information processing going on than what, you know, lots and lots of social cognition work with humans might suggest in terms of how special humans are. So in our next theme, we're going to add another layer to the social perception question, not just ask something about what stimulus cues and what an agent looks like, but also what do you as an observer believe about that agent. So when we talk about stimulus cues and knowledge cues, this is hopefully a pretty clear example, and hopefully some folks will be familiar with the Austin Power movies, which I'm sure are very dated now. But the basic idea is for stimulus cues, that robot in that picture there looks like a robot. But for knowledge cues, the robots that are surrounding the protagonist, Austin Powers, in the film, they just look like normal humans. But if you know what to expect, you know they're actually robots that hide deadly weapons in strategic places. So once you know that about them, you can't see them in the same way. So another 2x2 factorial design here, kind of playing off stimulus cues, so a human form or robot form, as well as knowledge cues. And this is where we're telling people that what they're about to see either has human origins, kind of made from really intensive motion capture procedures, versus computer origins. So we can show people videos and say that these have been made with kind of hands-off computer algorithms. In reality, everything has the same origins, but we use a very elaborate manipulation to kind of cover story to tell people more about how these videos were made. And in the paper, we have lots of details to kind of go into that in more detail. But essentially, people are seeing quite simple videos like you see there, and hopefully those are playing. And as you can see, there's no difference between the kinematics or really for anything going on there, but we're just telling people that they're about to see different things. And just to kind of whip through what we've seen here, we're seeing that there's actually a much bigger impact of stimulus cues to non-humanness in terms of engaging kind of not just early visual regions, but extending kind of anterior along the fusiform gyrus in the human brain. And in terms of our belief manipulation, when we tell people that they're about to watch videos that have human origins compared to videos that have kind of more computer algorithmic origins, here we see these are slightly more subtle effects, but that there's parts of the brain implicated with kind of more perspective taking and social cognition, such as precuneus, and the SPL that are more engaged when you believe you're seeing something with human origins. So in this final little piece, I'll tell you about make sure that we're okay. Okay, I know we're running out of time here shortly. We just took the same sort of manipulation that I just told you about, and we also now asked about, okay, if people aren't just watching these videos on the screen, as Eva very aptly put at the beginning, that's not what the real world's like. So we've taken one tiny step closer to the real world and into social interaction by using a very minimal automatic imitation paradigm, which essentially is just looking at the extent to which another agent's actions influence your own actions. Because we know that automatic imitation is kind of a real foundational building block of human social cognition and perception. I won't get into this in too much depth here, other than to say that across another neuroimaging experiment with kind of this much more interactive paradigm, we kind of see that there's some evidence that suggests that our actions behaviorally are showing kind of different patterns than what the brain is showing in terms of how our beliefs and stimulus cues to animacy are shaping perception and interaction. So again, there's more of that in the paper, but we'll just leave it at that for there. So what I can say to summarize here is that what these kind of preliminary studies have shown is that sensory motor nodes of the social brain, or the action observation network, seem to respond to both human and robot cues in terms of motion especially. And there's nothing really special about humans per se when we're thinking about these brain regions. Whereas the temporal parietal junction, and I did go through this result quite quickly in the last slide, but it's one part of the kind of social brain network specifically really seems to be more robustly tuned to humanness and does care whether something has human origins versus kind of simply is mechanical or comes from a machine or a computer algorithm. So that was some older work. I'm not going to go into this. This is just kind of a whistle-stop tour of some of the more recent work that my team is doing, where we're trying to maybe take a few steps towards these challenges that Eva outlined in her opening and in her opening slides, and that we're going to hear more about from other speakers. It's a complex space, but it's a very exciting space to be working in and to be trying to take up these challenges and to make some progress. And I'll just finish off with two quotes, which I think place this work again in a context that for why we should be interested in it and why many of us care about it. This technology writer, Eric Sofke, said that we're only barely scratching the surface of the brain's social algorithms, which become even more complicated and unpredictable when we interface with technology. This was said some years ago now. I think it's about 15 years ago, but that sentiment can't be more apt today. It is so true and so important. And then the health psychologist and social roboticist Elizabeth Broadbent also suggested in a recent paper that the further we go down the path towards making it interactive with artificial humans, the more truths we learn about ourselves. So again, coming back to this bi-directional benefit of kind of social neuroscience and social cognition feeding into social robotics and what we can benefit, we can each benefit with each other. I'd like to thank my fabulous team and funders, and thank you for your attention. And I look forward to the discussion later, and I shall stop sharing.